Hello everyone. Today let's solve the problem number 297, serialize and deserialize binary tree. So what the question states here, we are given a binary tree. So just give me a second here. Let's come to the example part. So yeah, we are given a binary tree. So we are given a binary tree. We have to design an algorithm to convert it into the string. We have to convert it into the string. So this one we need to convert this one into the string, and also we have to reconstruct the original binary tree from the string, nothing but deserialize. First one we have to convert that one to the string, nothing but we have to serialize. We have to serialize, and we have to deconstruct, we have to reconstruct, sorry, reconstruct the original binary tree from the string, nothing but we have to deserialize. We have to deserialize, right? So I'll just write ser here. So we have to serialize and deserialize in simple terms, right? So and then we have to return the exact same structure as input. Then we have to return the exact same structure as input. So input, the output will be same as input here. See, 1 2 3 null null 4 5, 1 2 3 null null 4 5. All we have to do is first one, here this one we have the method serialize, right? So within this one we have to convert this one tree into the string, nothing but we have to serialize, and we have to reconstruct the original binary string from the binary tree from the string, nothing but deserialize, nothing but madness. Basically we have to just serialize and deserialize, right? So that's what they have asked in the question. We have to do, we don't have any choice here, right? So here this is fine, this is fine. Now let's go with the approach. See here, the example 2 also, it consists of the same thing. Here the output is, we don't have any elements in the tree, so we'll be returning the empty array as output. So this is fine, I think. I hope the question part is completely clear, man. All we have to do is serialize and deserialize, convert the first thing into the string, convert the tree, this one basically, root, this one root into the string, and then we have to convert back that one to the original binary tree from the string. Means serialize and deserialize. That's what we need to do here. So this is fine. So what is the approach that we'll be going with mainly? So what is the approach that we'll be going with? So here we'll be going with the BFS, breadth first search, breadth first search, level order using queue. So we'll be going with a BFS with queue, basically BFS. So BFS usually will be going with a level order itself from the, I mean, by making use of the queue, right? So we'll be going with the BFS approach, BFS level order using queue, right? So just remember this one, that we'll be going with a BFS approach, right? So here first what we'll do, let's consider the first example, man. Just give me a second here, 1 second, 1 second. Yeah, so we will be considering this first example itself. We have already discussed this one, so it will be easier for us to understand the this one approach as well, right? So first here, we'll be considering this one. So we have this one input 1 2 3 null null 4 5, 1 2 3 level order. This one will be considering null and null, and this one as 4 and 5. So this is fine. So first what we will do, we'll start with the root. We'll start with the root. We'll start with the root, nothing but root value, the first one as 1, right? So this is 0th level, as indexing starts from 0. This is level also starts from 0. Basically this is 2. So this is 0 level, this is first level, and this is second level, right? At the 0th level or the root, so we have to start with the root one, and we have to add that one to the result, right? So we have to add that one to the result. First we will consider 1 1, we will be adding that one to the result. We will enqueue left 2 and right 3. So we have 2 and 3 as the sub leaf, this one leaf, right, for the one, sub children basically. This one, not the sub children, leaf node of, let's consider leaf node of 1, nothing but 2 and 3, right? Left leaf node is 2, right leaf node is 3, right? So here we will enqueue left 2 and right 3, right? So now we will visit 2, we will visit 2, we will add 2 to the result, we will add 2 to the result, we will be adding 2 to the result. We will enqueue its children null and null. We don't have any value here, we still have to consider this level, because for 3 we are having the children. That is the reason we are considering null null. We have the value for 3, nothing but 4 and 5 here. That is the reason we are considering null and null for the this one value 2. So first what we have done, we have started with the root, we have the children 2 and 3. So we will add 1 to the result for we will add 1 to the result, and we will enqueue 2 and 3. Now we have come to the left part here, 2. So we have added 2 to the result, we have added 2 to the result here. So we will enqueue null and null because 2 doesn't consist of any leaf node, right? So now we will come to the 3, we will visit 3, the right side of 1, we will visit 3 here, we will add 3 to the result, we will add 3 to the result, right? So we will add 3 to the result, we will enqueue 4 and 5, we will enqueue 4 and 5, because 3 is having the leaf node, left leaf node we are having the value 4, right leaf node we are having the value 5, we are having the value 5, right? So here we have visited 3 and we have enqueued 4 and 5, right? So now the next step is we will visit null 4 comma 5, this one. So we don't have any leaf node for this one. uh, this itself is null, basically we don't have anything. We still have to visit this one because we have the left leaf node and right leaf node for 3 respectively, right? So for 4 and 5 we don't have this one anything, right? Left and right sub children. So now what we have to do, we will be visiting null 4 and 5, and we will be adding that one to the result. R is nothing but the result, so we will add null followed by 4 and 5, as we are going with a level order traversal, BFS level order traversal, right? First level was 1, second was 2 and 3, then null 4 and 5. So we will be adding to the result and we will enqueue their children as null. So for this one we will enqueue this one as null, their children as null. Here also, this level also we will be enqueuing this one result as null itself, right? So result after serializing would be 1 2 3 null 4 and 5, 1 2 3 null 4 and 5. So this also we have considered null at the last one, right? So this one will be 1 followed by 2 followed by 3, yeah, followed sorry, 1 2 null. So this has to be null followed by 3, right? 1 2 null or 1 2 3 we should have considered. Just give me a second here, let me delete this one. I hope until here everything is clear, man. Let me delete this one. So now we have 1 2 level order traversal we went with, right? So this will be 1 2 3. Then we had considered this one, this part of null null, this is fine. And this part would be 4 5 we have to consider, right? 4 and 5. So this is 4 and 5, 4 and 5 as we have to serialize. So for null and null, as we have this what do we call particular level, this one is level 2, right? Level 1 and level 0. So we will be going with a null for this one as well, as we have having the particular level. So I'll just go with 5 followed by null next. In the next line I'm writing, so this one will be null again. And finally for this one also, 4 we are not having any value, 5 we are not having any value. So for this entirely, for 4 we'll consider null, and for 5 also we'll be considering null. So this will be null null and null. So for the serialization, we get the output this one, 1 2 3 null 4 5 null 4 times at the end, right? So this is the output that we get when we serialize, nothing but when we are converting the tree to the string. Next, let's come to the deserialization part here. What we will do here is, so we will split the string and create the root node 1. We will split the string and create the node 1. We'll split the string and create the node 1. We got 1 2 3. So null when we serialized 4 5 uh, finally 4 nulls at the end, 4 times null, right? So first we will split the string and create the root node 1. So now let's go with the 1 initially. So we will be using the queue to attach the children level by level. We will be making use of the queue to attach the children level by level. So this one will be again when we do that, it will be 1 2 3 1 2 3. So as we are dealing with the this one, as we are deserializing, will not be considering this one, this part. So finally null 4 times we have given, right? So that level we don't have any value, we will not be considering in the deserialize part. So this we have null and null. So this we have null and null. This one will be empty. So for now, just for the sake of understanding, I'll consider this one null and null. So finally, we'll come to the 3 part. Here, what we'll do, we will reconstruct left 2 and right 3, and then we will go for the 3. Then we'll go for the this one. We have to reconstruct 2 and 3, right? For the first 2 we have considered null and null. For 3 we will be considering 4 and 5. 4 and 5. So the final output that we get after deserializing would be same thing: 1, 2, 3, null, null, 4, 5. So the output that we got here is 1, 2, 3, null, null, 4, 5, which is equivalent to the output that they have given for the this one, example 1 within the question. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case, right? As we are completely familiar with the approach, part, let's move on with the this one, complexities part. So what will be the time complexity here? The time complexity would be big of the time complexity would be big of n here. So I'll just write it here. The time complexity would be big of n, because we will be visiting every node exactly once. We'll be visiting every node exactly once during both serialize and deserializing, right? So here overall time complexity would lead to big of n. The space complexity would lead to big of n as well, because for the queue and the final string building, we have we will be going with the queue, and for the final string we'll be storing the final string building as well, right? So here in this case, in both directions, uh, so basically we will be going with the final string building in both the directions, right? So still, yeah, it will lead to big of n itself. So the space complexity would lead to big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n for both respectively. So this is fine. Let me delete this one entirely. Now, as we are completely familiar with the approach, and complexities, we are good to write the code. Let's start writing the code. First, let's go with the this one. What do we call serialize method? Within the serialize method, what shall we do? Let's go with the edge case empty tree or the base case, right? So if root itself is null, means we are going with the empty tree, right? So we have to return null in that case. So let me come here. I'll just give here, if root equals null, then we have to return null. So this is fine. So the next step here would be, I'll just go with the queue. This one will be tree node. So this one queue, let me assign this one to the new linked list. So this is fine. Next I'll just go with q dot add of root. So this is fine. So the next step would be, let me make use of the string builder, as we have to convert this one to the string, right? So I'll just go with the string builder. So this one will be new. So let me copy the same thing here, string builder, and paste it over here. Just the syntax part, man. This is fine. So next step would be, as I have said, we'll be making use of the queue, right? As I've said, we'll be making use of the queue here. Just give me a second. Did I miss anything here? No. So I didn't miss anything here. Yeah, this is fine. So we we have to store the serialized output. That is the reason we have went with the string builder here. This is fine. And we have to start with the root, basically. We have to start with the root node, right? So, and also we are going with a queue for the level order traversal here, this one. We are making use of the queue, right? So this is fine till here. Next, let's go with the queue part, man. While queue is not empty, well, not of queue dot, let me make use of is empty. This one, what do we call? Uh, is empty operation. So here within the while loop, what we'll be doing? So we have to get the current node from the queue. I'll just go with the variable node, and let me assign this one to the queue dot poll. So to get the current node from the queue, I'm making use of the poll operation that the queue provides, basically, right? So this is simple. Let's go with the simple if condition here. This will be if node equals null, if the value we have as null, then we have to append that null for the missing child. Then we have to append null for the missing child. If you remember, 2 didn't had any here. See, 2 didn't had any, or 2 is not having any this thing. What do we call values, right? At this particular level, we have the values for 3, 4, and 5. But for the node 2, we don't have the uh, children, left and right subtree. So what we'll be doing, we'll be appending that null. We'll be appending the null for the missing child. So I can just write here on this way. Uh, String builder, nothing but SB dot append of this one. Let me give null here. Null. This is fine. Null. I'll just give comma in case two nulls we have to go right here, left and right subtree. So for that purpose, I'll just give null comma here. This is fine. So else what we need to do here, else what we need to do, we have to append the current node's value. If we have the value, if we have the value, suppose we are considering 3 now. If we are having the value for 3, right, 4 and 5. If we have the value, then we have to append the current node's value. Then we have to first append the current node's value, nothing but 3 here. This will be string builder dot append. So this one will be node dot value, value of the node, and we have to append comma as well, because we have 4 and 5 value as well. Value 4 and 5. Next we have to go with value 4 and 5. So let's do one thing. So let's append the comma as well here. So this is fine. So we are just appending the current node's value. Next, what shall we do? Let's enqueue left child. Let's enqueue the left child. Nothing but it can be null. It can be null. Here, let's enqueue left and right child basically. So I can just write it on this way. Q dot add of node dot left. So we are just enqueuing the left child. Now we have to enqueue the right this one, right child as well. So this one will be q dot add of node dot right, node dot right. So this is fine. So let me come out of this one entirely. Let me come out of this one entirely. uh yeah, this is fine. Finally, let me go with the return statement here. We have to return the final serialized string. So I'll just go with return string builder dot. So this one will be to string to string. So this is fine. Let me come out of this one entirely, man. Let me come out of this one entirely. So this is fine. So we are done with the serialization part. Let's go with the deserialize method, right? So here, basically deserialize, what it does, we have what we need to do. We have to convert the serialized string back into the original binary tree. This is pure madness, but we have to do it, right? So if the data is null, then we have to return the empty tree. If the data is null, then we have to return the empty tree. So here I can just write it in this way. So this is data dot equals data dot equals. So let me give here data dot equals of null of null. So this one, let me go with return null. Let me go with return null. Nothing but if the data is null, we have to return the empty tree. So next, what we have to do, we have to split the string by commas into the node values again, right? So we have to split the string by commas into node values. Similar thing we have done on the this one as well, in the line number this one 15, and in the line number 13 as well, right? So we'll be doing the same thing. I mean, we'll be doing the similar thing here. So string this one nodes, I'll just assign this one to data dot split. So yeah, data dot split here, this one, this is fine. Next, what I'll do here, we have data split, this is fine. We are just splitting the string by commas into the node values, right? So next, we have the first value, that is the root. First value is always the root, right? So I'll just go with here tree node root, that is equal to new tree node of this one will be integer dot percent. This one will be nodes of 0, nodes of 0. This is fine. uh, Next step is as we are making use of the queue, as I've said, we'll be making use of the queue here, and the deserialization also, for the deserializing also we'll be going with the queue. Basically we'll be making use of the queue to reconstruct level by level, means level order traversal we'll be going with, right? So I'll just keep here queue. So this one will be tree node queue. I'll just consider a variable name queue here. So this one will be new linked list. So this is fine. Next step is we have to start with the root node again, the same thing. So this will be q dot add of root. Some of the things will be similar, man. Similar. Uh, we are just deserializing the same thing back to the binary tree. First we had the binary tree, we have to change that one to the string, we have to convert that one to the string again. In the deserialize, what we are doing again, we are deserializing, means again we are converting that string back to the binary tree as per the question, right? So q dot add of root, uh, so this is fine. uh, we have started with the root node. Now we have to go with the index for traversing through the nodes array, means here I'll just go with int I equals 1, right? So let me leave space here. So this is fine. Now let me go with the while loop here. While not of q dot is empty. So this is fine. So within the while loop, we have to get the parent node first. So this will be tree node. So this will be current. So here I'll just consider, as we need to get the parent node, I'll be making use of the poll operation that the queue provides. So this is fine. I hope this part is completely clear. Now, the main thing is we have to process the left and right child. We have to process the left and right child, right? So let's write the same, this thing, code for it. So let's articulate the same thing that we have discussed on the approach. We have to process the left and right child. First, let's go with processing the left child. So let me write the simple if condition here, dot not of nodes of I. So I'll just make use of equals equals null null. Then within this if condition, let me create the left child, nothing but here current dot left. Let me go with new tree node here. This one will be integer dot percent. So this is fine. uh, this is just the percent one, percent of nodes of this one, nodes of I. So this is fine, nodes of I. So we are just creating the left child here. So this one will be q dot add of current dot left. This one will be q dot add of current dot left. This is fine. So this is what we have done here. We are going with the enqueuing left child. We are going with the enqueuing the left child. So this is fine. Hmm. I plus plus, so we are just incrementing the I, or we are just moving to the next index basically, right? So we have to process the right child now. So let me copy the same thing and make the necessary changes, man. So here from the line number 36 to 39. So I don't want to type this one again. So this one remains same, equals null. Instead of the current dot left, this will be current dot right. So new tree node remains same. This one nodes of I, this remains same. Instead of the this one, we have to enqueue the right child instead of the left child. So I'll just go with the current dot right instead. So again, we have to move to the next index. So I'll just give here I plus plus. So I hope this part is completely clear. We are almost done with the code. The only part is we have to return the reconstructed tree rows, a tree's root, nothing but we have to return the answer basically. So here we have considered root itself, I think. Yeah, this is root. This is fine. Let me do one thing. Yeah, let me come here. So I'll just give here return root. We are just returning the reconstructed trees root. So let me format the code once and let me hit the run button. So I hope this works for all the test cases, man. Let's see. Double dot, where line number 13. So let me remove one dot here. So this one has to be SB, right? String builder we are making use of. Uh, this has to be string builder, right? This is SB. Yeah, this is fine. Next, mm, so just give me a second here. Yeah, string by. We are appending null for the missing child here in this case. This is fine, man. Now let me run this one again. What error we have got now? So expected semicolon here. I have missed the semicolon, line number 13. Yeah, let me give semicolon here. Now this has to work. Let's see if everything goes well. Yeah, so you can clearly see here the sample test cases are getting passed. Means the code works absolutely correct for the sample test cases. Let me hit the submit button. I hope this works for all the test cases, man. Let's see. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct for all the test cases. So I hope the solution part is completely clear along with the complexities and approach, right? For now, this is it. Thanks for watching, guys.